Alrighty, let's go ahead and get started. So hello and thank you for joining us today. I'm Jen and I work with the OpenDDS Foundation and the OpenDDS team here at OCI. And we're pleased to have some of our OpenDDS engineering team with us to talk about dynamic data. So I wanted to just remind everyone you are muted for this session. We will do a live Q&A session at the end and answer as many questions as time allows. So as a reminder, just load up those questions in the Q&A section as you have them. Also, we are recording and do plan to make it available to view on demand shortly after. All righty. So today we have Adam, Justin, Fred, Son, and Tim joining us. Adam, I believe you're starting off first with the agenda.
Sure. Thanks, Jen.
Yeah.
And thank you everyone for joining. Welcome. I do see one person that says hand is raised in the webinar. So if you have a question, maybe good to put that into chat and we will try to get to it as soon as possible. Okay, one kind of preliminary slide here. We'll be talking about a specific group of features today called dynamic data. But of course, there's a lot more to OpenDDS. It's a relatively full-featured framework for distributed computing. So we wanted to mention, training classes that we have in our curriculum that can be delivered online or even in person. And so if you're interested in learning more, that's one good way to do it, but there's lots of resources available. Okay, with the preliminaries out of the way, let's take a look at our actual topics for today, our agenda. So start with the right-hand side of the slide. You'll see that there is an application called an opendds-monitor that is a graphical user interface, and we'll be talking about that and demoing it and when we get to that part. But that sort of motivates, in a sense, what we're doing here with the middleware features of dynamic data. We'll get into what all that means in a few moments. So over here on the left, our agenda for the session today, we'll do some of the overview of what is XTypes and the dynamic data parts of XTypes in particular. We'll look at some usage patterns, why you might want to incorporate this into applications, and then review the existing features that support dynamic data in OpenDDS, and then new capabilities that will be in our upcoming release. And we'll finish up with some demos and we'll talk about next steps, right? What else can be developed that's not there yet? And as Jen mentioned, we'll have Q&A. Yeah. And with that, I will turn it over to Justin.
So to really start talking about dynamic data, we need to start at XTypes. So XTypes stands for extensible types, and the specification is given there in the link. XTypes gets around the assumption that all participants are using the same types. And the point in doing so is that it allows us to be more interoperable and evolvable. That is, if you consider you have a very complex system where you don't necessarily own all of the pieces, if you will, or you don't have control over all the pieces, it becomes very important to allow different subsystems to change and move forward without breaking compatibility with the older pieces of the system. So this is really helping DDS move beyond, small closed systems into systems that have a much bigger marketplace, and you're allowed to interact with software, which is not necessarily software that you've produced or you have absolute control over. So XTypes introduces a thing called a type object, which are portable objects for topic data types and all of the dependent types within a topic data type. And they also have an extensible encoding for these, and that's based on an RTPS standard, and the encoding is called XCDR2. There's an older XCDR version 1, but XCDR2 is the most recent one. So these portable type objects, different DDS participants can exchange them using RTPS discovery. And once they have them, they can then reflect on the data samples that they get for that particular type. So a type object describes the schema of a type and the extensibility of its members. So the schema is relatively straightforward. It just says that the struct has a field that is a double and named temperature or something like that. But the extensibility says how that particular type is allowed to evolve. So for instance, a struct could have a new field added. That would be an example of a mutable extensibility. And say that you define a number of fields in that struct, but maybe an older version of the software or an older writer doesn't necessarily write all those fields. You can provide default values for those missing fields. So the extensibility is really important in terms of allowing interoperability, both forward and backward compatibility. So let's move to the next slide. So XTypes can be used in either what we're calling statically or dynamically. So in the static scenario, you have type objects that are derived from annotated IDL. So the mutability, all the extensibility is defined through annotations. In your IDL, that gets run through an IDL compiler, and the IDL compiler is responsible for generating type objects or things which can be converted to type objects. An application that's going to be writing using a statically typed data writer, which is typically some kind of template, which is parameterized by your message type. It's then going to accept objects of the type, being like C++ or Java or whatever you're using. So there's a type defined in the programming language for that topic type. And the data writer API accepts objects of those types. The reading application, it behaves in the same way, where it's got a data reader, which is typed on the particular, or parameterized on the particular data type. And it then interacts with the C++ or Java object types. Underneath, what's happening when there is a discrepancy is that the middleware is going to make the sample right for the reader. So if there are additional fields or fields that need to be defaulted, the middleware takes that responsibility so that by the time it gets to the actual static data reader, the sample is using the locally defined type as opposed to the type that was originally used by the writer. And all of this is the idea of type assignability, which is defined in the XTypes spec, which says that which has the rules for saying that one type is assignable to another. So long as the type of the writer is assignable to the type of the reader and the topic names match and all the other stuff that happens for RTPS discovery, then those are compatible and an association can form, and the data reader can receive samples from that data writer. So let's go to the next one. So this gives you an example of kind of how this works with the plain language binding. So on the left, where it says IDL, we have a struct that's annotated with a topic, meaning it's a topic type. And this has three members, a state, a level, a temperature. So imagine this is like a light control that you can turn on or off. You can adjust its intensity and you can adjust its color temperature. Code generation allows that to be converted to a C++ type, which essentially resembles the same thing with the struct. But there's also an additional piece of metadata called the type object, which is then made available to the middleware to where it can publicize that in discovery. So the application, in its turn, when it's writing, defines or instantiates an instance of light control and then sends that to the typed writer. So even if a reader has a slightly definition of light control, say it has an extra member or something that it wants, and it is willing to default that extra member, then it would be compatible with a writer that doesn't have that type of member, and vice versa. The writer could define more fields than what the reader expects. So let's move on to the next one. In the dynamic scenario, we'll move away from IDL. So In the dynamic scenario, the type objects are going to be constructed programmatically or received from a peer process or peer processes, or perhaps even loaded from a library. So we're not necessarily going to allow the IDL compiler to derive the type object, whether or not we're just going to assume that one exists, or we're going to assume that one can be built. With a type object in hand, you could instantiate a dynamically typed data writer based on that type. And you can also instantiate a dynamically typed data reader. The API that you're going to use has an abstract interface called dynamic data that includes the type descriptor. So you would programmatically build up the type first, instantiate the data writer or data reader. If you're on the data writer side, you would then create a dynamic data object that's based on the type that you created. You would then initialize all of its members using that API, and then you're able to write that sample on the dynamic data writer. On the data reader side, again, you receive this dynamic data object. You can then inspect it. You can inspect its type and interact with it via the API that's defined. So dynamic writers can interoperate with static readers and vice versa. And again, since the middleware is making it right for the reader, the nature of the writer is irrelevant to the reader and vice versa. So the subset of XTypes that deals with these dynamically constructed types and samples is called the dynamic data. It's called dynamic data and the dynamic language binding. Next slide, please. So in this particular case, in the dynamics thing, as I said, we're not using IDL anymore. So the application creates a type. We assume that the type has already been created for us. It's in that type variable. You then go to the dynamic data factory, and you're going to create a new sample from that. That's that dynamic data var DD. From there, you can then use the API to populate it, setting its members to certain values. And then once you have initialized it the way that you want, the data writers then accepts that dynamic data instance and go ahead and writes the sample. So there is no, you know the structure of the topic, which you've defined either programmatically or through a library or something like that, but there is no direct C++ mapping. And the dynamic data container, if you will, can store any type that a DDS implementation can support. You may not support, an implementation obviously may not support all of it, but that's the general idea, is that an implementation would eventually. You still get type checking in the sense that the compatibility of the reader and writer is checked. And there are certain things to where if a writer fails to include a required field or something like that, then that sample can be rejected. So it's very impactful, I guess, or exciting about this dynamic data binding is that with this API, you can then reflect on the type of the sample that you're working with. You can interact with static things dynamically and some other things, which I'll get into in the next slide. So let's go to the next one. So how would you use dynamic data, or what are some common use cases? So one, the first two here kind of come in a pair, and that is you can create a recorder. So an application could record samples for analysis or playback. So in this particular case, the recorder doesn't necessarily care what the structure of the topic was, other than it wants to record that data so that another application can analyze it or play it back. The playback would be done by an application called a replayer, which would essentially load all of that data in and then play it back out. Or maybe it does dynamically generated samples based on those, or just dynamically generated samples in general. So the replayer, again, doesn't really care about what the type is, other than it knows that there's data that needs to be written on a particular topic. You can also, using dynamic data, you can create monitoring and diagnostic tools. So these are applications that can show or analyze samples on arbitrary topics without a compile time knowledge of those types, and that's very important. So these applications can learn the types of various topics through discovery. And then based on that information, they can reflect upon it to generate a UI or log, or even allow someone to interact with it, which kind of gets into our next one, without the compile time knowledge, because that knowledge has been derived from the existing readers and writers in the system. So kind of in the same vein, you could make a test harness or a driver, and that's going to be an application that can write samples on arbitrary topics. So a common usage is that you have kind of a system or a unit under test, and you need to make some kind of front end that allows people to interact with it and put it in certain states for testing. So dynamic data allows one to do that without necessarily hard coding and making a lot of assumptions in the UI component, but rather they can reflect on the type of the actual unit under test to present a UI that's appropriate for the user. Finally, you can, with the dynamic data API, you can do generic message handling. So for instance, even if you're using static readers and writers, it may be advantage to interact with that sample through the dynamic data interface for something like logging or redaction or something like that. So you could take all of the samples that you received and log them through a common interface that knows how to serialize those to, say, JSON for logging purposes. Or maybe you have sensitive information like a password or something in your sample. So you can pass that through a generic filter that knows how to look for fields named password and redact that information. So then finally, one use case that's used even internally in DDS specifications is that of DDS security. So DDS security defines instance level security measures where as writers register, unregister, dispose, etc., instances, that those can be checked. And those can be checked locally or remotely. And the APIs for those are based on dynamic data, where the DDS security plugin receives a dynamic data object and is expected to use the dynamic data API to verify that that instance should either be allowed or not allowed. So with that, I will turn it over to our next speaker.
All right. Thanks, Justin. All right, so I'm going to talk about, since Justin got all the terms and such out of the way, I'm going to talk about like what actually we support now and what we are going to support soon with these added dynamic data support. So right now we support the recorder or player, as Justin talked about. These, at least like by themselves, they just deal with raw byte streams of a topic. You would have to do additional processing on them, at least when they were added, to do anything useful with them, unless you wanted to immediately send them out in the root layer. Static XTypes is basically our current like normal typed IDL and the mapping from that IDL support for all that. And that includes like the extensibility and the support for immutable types. We do have partial support for dynamic data for reading, but that's only really for the recorder. But right now that is used by the inspect tool, which allows you to specify a type in a topic, and it will listen to it and print out the samples it sees. There's a lot of tools to do that, but this specifically uses the dynamic data. All right, I think ready for the next slide. So the upcoming release, 3.23, as we've been talking about, it extends the support for dynamic data and the related interfaces, specifically dynamic data writer and dynamic data reader. So the big caveat on this is the types have to come from somewhere where the types are already defined, and that can be a existing type support library. So so this is the same like shared library that if you were to generate a separate shared library, you could load those up. And without the application specifically knowing about it, it can use the dynamic types dynamic data writer or data reader interfaces. Or it can, if it learns about a type or topic that's being published or listened to remotely, like a remote data reader or remote data writer, it can get the dynamic type for that and then read or write to it. Right now, we don't support the creating these types dynamically, at least not yet. It's close though, so we will probably have that soonish, though I can't say when. And then in addition to that, we are separately releasing what we're calling the opendds-monitor. It's separate from the existing monitor tools of the same name, in that it is based on this XTypes APIs that we've been working on, and will hopefully be better because it's spec based, and we'll be able to extend it, and as we extend our support for the spec. Okay, ready for next slide? All right, so right now I wanted to get into a demo for actually using this dynamic data. And for this, we're going to take some IDL from our original XTypes webinar, or at least the idea for you have vehicles in a rental car company, and you want to know like how are they doing. So you would have say a VIN for identifying the specific vehicle, and then maybe the oil level and fuel level, basic things. And then in this first demo, we're going to demonstrate how a dynamic data writer could make use of the new interfaces to publish to a existing static application. And in this case, it's going to be loading the type support library from a shared library. All right, next slide. Okay, so this is a video of me doing this. So we're going to see if I can keep in sync with past me and dubbing over it. All right, so on the right, we have a traditional statically defined type using the traditional like typed interfaces. And it's just reading a fixed type in a loop, and it's going to print the samples it gets them. On the left, we have a application that's using the new dynamic data writer interfaces, and it's loading a shared library called vehicle health and a vehicle health 1 type from that library, and then it's going to be publishing to vehicle health topic. And then the rest of it, the ABC 20, that's the data it's going to be stuffing into a dynamic data that it's then going to be writing to the topic that it got. And there it goes. And there it is on the other side. So let's say that the vehicle's been going along for a while, so we're going to take some fuel away, or at least simulate that. And there it goes. And on the other side, it goes from 1.5 to 1.3. So that works. So let's say we actually wanted to change the type this time, and we wanted to do, like, say we wanted to see what the battery was doing. And let's say it's just a basic like A to F like grading scale. Well, the problem is the type doesn't have that, and we can try that. And here I'm putting in C, but it doesn't work. It doesn't have that many types. But the type library does have a type, actually. That's why I called it vehicle health 1. There's also vehicle health 2. And it does have that grade. And there you can see the other side got it. And the other side's actually using that type, and it could work with both of them because of the standard the type compatibility that works through the standard XTypes mutability. So that works. I think we're ready for next slide. There we go. Okay, so here's a simplified view of how to get that dynamic type from type support library. So first we want to load it. Here we're using the ACE DLL class, but you could also use, if you're on Unix, Linux, whatever, you could use DL open or the equivalent on Windows. But this should work on both of them. So it loads that. And then we have to get the type support, and we can get that from the registered data types class in OpenDDS. You can search for it by name. And then from there, you can get the type from the native type support. We can't use the native type support if we can't like compile against it. So we have to get the type, and then we could create what's called dynamic type support from that. And dynamic type support's the same as regular type support classes from other things, but it specifically works with the dynamic types. So you can create dynamic data readers and writers from it. And you'd have to register it like normal, and you just hope that works. And you should be able to create the dynamic readers and writers as normal. I can go to the next slide. So, and then the other use case is to get the dynamic type from a remote peer. And to do this, you would have to subscribe to the publication or subscription built-in topic. And there's a field in there called key. And it will identify that remote entity that is publishing. And you can pass that to a function in service participant called get dynamic type. And this will actually work for, I think, local types as well, but the idea is to use remote types. And if it has the type information, it needs to be able to handle the type locally. It will just return the type information it already has. If it doesn't, I think Justin touched on this a bit, where we have to publish type information. Well, we can get more type information that we need if we don't have it, and it will do that automatically. And if it returns all okay, the type will be initiated, and then you can pass it to the dynamic type support as before, and then you can continue as before with creating dynamic data writers and data readers. And then I think that's all I have. And from here, I think I can hand it over to Son.
Okay. Thank Fred. So in the previous slide, we have seen a demo, an example of a static, a dynamic data writer talking to a static data reader. And in this part, I'm gonna talk about another use case of dynamic type. That is, we can use a static publishing application to talk to a dynamic subscribing application. This is an use case which Justin and Fred also talked about in the previous slide, which we can use for analysis, for recording, or for monitoring purpose. So there are a couple of tools for OpenDDS that can do this. The first one is the inspect tool. In the same OpenDDS repository. It use the recorder interface of OpenDDS and can listen to like an exact topic with an exact a specific type of that topic, and then can print out the content of the any sample that are published to that topic. The second tool is called opendds-monitor. This one is pretty relatively new tool that we are working on, which can create a dynamic data reader to subscribe to any topic in the domain it want to listen to. So I'm gonna share my screen for my demo. Can you see my screen?
Yes.
Okay. So for the demo, I have a simple public source which publics to a topic with this idea. So I showed the idea for this public source. So it pretty similar to the demo one that Fred talked about. So we have a vehicle topic, vehicle health topic with a VIN of the vehicle and the oil level of the vehicle. And the topic name is vehicle health. And the first tool I want to demo is the inspect. It's located in the OpenDDS repository and under the tools subdirectory, and you can like run have option to see how it gonna be used. So basically, to listen to a topic, you need to pass the topic name and the type name of that topic, and also the domain ID where the topic is published. And so for this example, the topic name is vehicle health, and the type name is demo vehicle health. For the type name, we need like fully qualified namespace for the type name, and the domain I'm gonna use is 111. So it's going to create a recorder instance which will listen to that topic. And then here I'm going to run the public source which will publish this topic. And this public source will publish the samples to the topic once in every 3 seconds. So the inspect will then the inspect to learn the type of the topic, like using the type object through the discovery process, and then it know about the structure of the type, and then it can inspect the individual member within the type and print out the value of the member. So okay, so I think it worked for inspect. Now I'm gonna move on to the monitor tool. One thing I want to note for the inspect tool is that it can only inspect a specific specific topic with a given type, but it cannot listen to like any type or any topic. But that is the thing that monitor, the OpenDDS monitor tool can do. So when I run the monitor, it will ask for the domain that I want to listen to, and the domain for the publisher is 111. And then I run the publisher again. And then the monitor will be able to discover the topic vehicle health. And when I click on the vehicle health topic, it's gonna show another tab with the samples for this topic. And on the history column is a list of timestamp for the sample it received. And the next table is the name of each member in that topic, and also the type of the members and the value of each sample. And internally, the monitor tool use the facility to get the dynamic type from for the remote topic that Fred talked about in the previous slide. And it is able to listen to any topic with any type in the domain that we specify. And I think that that's it for the demo. And I can take another slide. The next slide. So at the current state, we have a list of the next step we want to do for dynamic data support. The first one is content filter topics and other content subscription feature. Right now, we don't support these feature yet, but soon we will add it to our OpenDDS release. And the second thing is opendds-monitor tool, the tool which I just show you in the demo. This is a pretty new project which we are actively working on, and a couple of things we want to improve on the tool is for it to be able to render a more complex type in the UI. Currently, it is limited to like some basic type. We want to it to be able to display any type, like basic type, complex type, and nested type, so on. And the second improvement we want to do for the monitor is for it to be able to write data sample using dynamic data. Right now, it is only be able to read dynamic sample using dynamic data, but the writing part is also useful for some use case, so we want to add it. And then the third thing we want to add for our dynamic data implementation is constructing type at runtime. So like Fred mentioned in before, right now we can load the type from the IDL, and basically all of the type we support are from the compile time, but we want to be able to construct type at runtime using an interface called dynamic type, which is part of the XType specification, which go along with the dynamic data interface. And the last one is support for XCDR1 data representation. Right now, which the one that we support is XCDR2. Supporting for XCDR1 would require a little bit change to the detail of how it serialize the type, but we would like to add it to our implementation as well. I think that concludes my part, I would like to hand it over to the next person.
All right, thanks, guys. So if anyone has any questions, please go ahead and put those in the Q&A and we'll get started answering those. Again, thank you for your time joining us, and thanks, guys, for the presentation. So we will hang out here for a few more minutes, waiting to see if there's any questions. It looks like we have one that's popped up in here. How is the security for the dynamic part? One of you guys wants to take that?
Sure, I can take that. Thanks for your question. So DDS security, we can think of it as kind of running at like a layer underneath where the language binding is happening. So all the same DDS security features that are in OpenDDS can apply whether you have use of the static language binding, or the spec called plain language binding, or the dynamic one. So, encryption, establishing identity with certificates, access control, all kind of happens the same way. And in many scenarios, those access control decisions are based on, which topic it is, right? So a given, identity in the system could have, read-only access to a certain topic, right? So that applies whether or not it's dynamic, using a dynamic data reader. There's one feature that Justin mentioned back towards the beginning of the presentation, where internally a dynamic representation of data is useful for kind of the core of OpenDDS to interact with a security plugin. And that happens when access control decisions are made based on the instance being read or written and not just on a topic. So it kind of lets you go one level below that, right? So not just granting access based on topics and partitions and domains, but also on the instance. And that's all kind of transparent to the application layer that's happening, within OpenDDS middleware and how the core libraries interact with the security plugin.
Thanks, Adam.
And if other panelists have additional things to say about security or anything else we may have, we may want to circle back to, that's okay too.
I've got a question for the rest of the panel. Just to not sit here in silence. What's necessary to get existing applications to be able to use the monitor? Are there any extra steps required? Does anybody else want to answer?
Yeah, thanks for bringing that up, Tim. The dynamic data features are based on complete type objects. There's two sorts of type objects defined by the spec, minimal and complete. So as long as the code generation for type objects uses the complete type object and that option is enabled, so there's kind of a code generation part of it from IDL and a just a configuration option for when you're setting up OpenDDS. As long as the complete type objects are supported in XTypes, then those dynamic features will work with the monitor application or any other dynamic application.
Yeah, and that's also required for getting the because it's using the same feature. It's also required if you wanted to get the type support from base it off of peers type.
Alrighty, I'm not seeing any more questions come through. We have a few more slides that are just reference slides. If anyone wants to reference those, as I said, we recorded the session and we'll include the slides in what we provide as well. So you'll see that there's just some further or some links to some additional on-demand resources as far as webinars and articles, and it looks like the repo is also listed here if there's anyone that wants to read up on any more OpenDDS exciting topics. Here, Adam has posted information about the OpenDDS Foundation. We're really excited to have the foundation supporting the OpenDDS project. We started this earlier this year, towards the end of last year, and we have a technology advisory board that helps advise and guide the project. So we're really excited to have the foundation and have folks from the community be a part of it. So if anyone is interested in learning more, there is a link here. You can get to it online as well through opendds.org. And if there's any additional questions, please don't hesitate to reach out, and we hope to see everyone in future offerings that we have. And those we'll start populating a schedule for that for next year soon. So thanks again for your time, and everyone have a good holiday season and new year.